So like I said, this is chapter 27. It's all about interference and diffraction. All right. And there's a couple ways you can get interference and diffraction with light. You can have an experiment where you have something called a double slit. So that's sending light through two tiny little holes. Looks something like this. You send light in, and that light kind of ends up as two little waves of light, and it forms a little pattern on a screen behind it. Pattern that you get, you have bright spots followed by dark spots, and as you go from the central bright spot, it gets a little bit dimmer. So that's what that's representing. Right? We get a whole bunch of light in the middle, and then we get a little bit less light, but we get kind of equal amounts on two ends, and then that pattern repeats. And you'll see this in the lab when you're actually doing this. And there's some math that describes all of this, and the equations for that, for getting bright spots. We can actually calculate these. The equation we have is something called m lambda equals d times sine of theta. And here, m is something called the order, and it's equal to 0, plus or minus 1, plus or minus 2, so on and so forth. So what do all these things represent? M, like I said, is the order. That is the number of the bright spot. So if you're at this middle bright spot, your m equals 0. If you're at a bright spot that's above it, m can be equal to 1. If you're at the bright spot that's below it, m equals negative 1. D is how far apart the slits are. So these two little guys right here, the distance between those two is d. And then sine of the angle, it's not really this, but it's close enough. If you draw a line to the central bright spot, and you draw another line to the first bright spot, and draw a right triangle, that angle right there is roughly theta. Close enough for our purposes. None of you are going to be professional physicists, right? No? Yeah, this is good. This will get you there. So we can produce bright spots. We can also predict where all these dark spots are in the double slit. We can predict the dark spots, which are going to be these places where there's less light. So right here and right here. We can predict all of those with an equation too. The equation we use there is m plus 1/2 times lambda equals d sine of theta. Here, everything represents the same stuff. M is equal to 0 for the first dark spot. So if m equals 0, you have this m plus 1/2, so 1/2. So it would be this spot and this spot. These two dark spots, then these two dark spots. The one thing I didn't tell you is what lambda was. And that's because we should already know. What does lambda represent? Wavelength. That's the wavelength of the light that you're shining through. When you get the equipment that will set up, the wavelength that you're going to use is written on the actual laser, because you're going to do this with laser beams. I think it's 650 nanometers, but we'll double check that. Okay, this double slit equation, it doesn't only work for two slits. It works if you have something called a diffraction grating, which is a whole bunch of slits. So this is multiple slits. Also called a diffraction grating. And with the diffraction grating, with multiple slits, more than two, you can only predict bright spots. You can't get the dark spots. But you predict the bright spots with the same equation. M lambda equals d sine of theta. M again here is 0, plus or minus 1, plus or minus 2. And D is, again, slit separation. But you have a whole bunch of slits here. usually they give you D, the slit separation is 1 divided by the number of lines per centimeter that is inside of this diffraction grating. So it tells you how close all these things are. This says slit separation. Chicken scratch handwriting. Okay, so that works for double slits, works for multiple slits to get the bright spots. Can't get the dark spots for the multiple slits. The last thing is a single slit interference pattern. This is when you have just one little line that you shine light through. And oddly enough, this gives a pattern. You get a little pattern on the back screen, a couple little spots. Here, we'll do it the same colors that you're going to see when you actually do it in the lab. You'll see little red splotches. And that's from shining one piece of light in. That light actually interferes with itself, which is crazy and weird, and quantum physicists still, I think, have no clue what's going on there, even though they would claim differently. What you're getting here is something called destructive interference. This is in the lecture. This is talked about in the book. Destructive interference is when you get dark spots, so light canceling itself out. And you can use an equation to predict this. This is a little bit weird, but the equation that you use to predict these dark spots, m lambda equals d sine of theta. D is the slit width, size of that slit. Why is this equation weird? What does that equation look like? Looks like the bright spots. It's the exact same frickin' equation. But what is this one predicting?
Dark spots.
Dark spots. So when you have one slit, you use the same exact equation, but the pattern you get out is actually the pattern that you get from bright spots. But you're getting dark spots because there's one slit. So in single slit diffraction, you are predicting where the dark spots are. But you're using the same equation that gives you bright spots. So it's very weird. But that's just the way the physics works. So this is all observational or empirical kind of results. It works this way because that's what we observe. And again, M is still the order that you get. And in this case, M is a little bit different than the bright spots. Where does M start when you're predicting the bright spots? What's the smallest M value you can have?
In the middle.
Smallest M value I can have. It's in the middle. What's the smallest number?
0.
0? Okay, so I have the 0 spot and then a spot above and below, plus or minus 1, spot above and below, plus or minus 2. Here, you don't have a middle dark spot. So your order for the dark spots actually starts at plus or minus 1, plus or minus 2, plus or minus 3. So that's another weird thing to keep in mind. You've got the dark spots, plus or minus 1, plus or minus 2, plus or minus 3. So that's the differences between single slit and multiple or double slit. And that should be enough to do all the problems that I assigned. And should be enough for you to understand what's going on in the lab. So while you work on the quiz and work on your homeworks, I'm going to track down all the equipment you need and show you what it actually looks like when you set it up. Yep. Fantastic.